Now, the terms of the series being tested must be smaller than those of a convergent series or larger than those of a divergent series. If the terms are larger than the terms of a convergent series or smaller than those of a divergent series, then the comparison test doesn't apply. So let's consider, for instance, the series 1 over 2 to the n minus 1. And the inequality would be 1 over 2n minus 1, which would be greater than 1 over 2 to the n. It is useless as far as the comparison test is concerned because the series is equal to, or the series of b subscript n is equal to 1/2 to the nth power is convergent, and therefore the first series is greater than the second series. Nonetheless, we have the feeling that 1 over 2 to the n minus 1 ought to be convergent because it is very similar to the convergent geometric series 1/2 to the nth power. In such cases, the following test can be used, which is called the limit comparison test. Now, suppose we have two series, and those series with positive terms. If the limit as n approaches infinity of a subscript n divided by b subscript n is equal to a constant c, where c is a finite number and c is greater than 0, then either both series converge or both diverge. Although we won't prove the limit comparison test, it seems reasonable because for a large n, we can say that a subscript n is approximately the constant times b subscript n. Now in example number 5, we're going to use the limit comparison test to test a series of 1 over 2 to the n minus 1 for convergence or divergence. Now we're going to use the limit comparison test. So a subscript n is going to equal 1 over 2 to the n minus 1. B subscript n is going to equal 1 over 2 to the n. And then we're going to then obtain the following. We're going to take the limit as n approaches infinity of a subscript n divided by b subscript n, which is going to equal the limit as n approaches infinity of 1 over 2 to the n minus 1 divided by 1 over 2 to the n. Now, rewriting this would be 2 to the n divided by 2 to the n minus 1. And now if we divide the numerator and denominator by 1 over 2 to the n, then we would take the limit as n approaches infinity of 1 divided by 1 minus 1 over 2 to the n, which is equal to 1 over 1 minus 1, which is equal to 1, and 1 is greater than 0. Now, since this limit exists, and 1 over 2 to the n is a convergent geometric series, then the given series converges by the limit comparison test.